Okay? Many ways to represent the line. Now, let me talk about the slope a little bit more. What if you have two lines and you know that the two lines are parallel to each other? What can you say about the slope? Parallel lines, they're going to have same slope. Okay? What if you have perpendicular lines? Perpendicular lines. Now what? The product of the two slopes will be equal to -1. So M1 times M2. By the way, M1 means slope the first line, M2 is slope the second line equal to -1, or people may write this way. M1 is equal to -1 over M2, and they say what? The slopes are opposite reciprocal, okay? Opposite reciprocal. Okay, so opposite reciprocal, this is what it means. So you got 3/5. The opposite of 3/5 is -3/5. Reciprocal of this is -5/3, okay? So opposite reciprocal of 3/5 is -5/3. Okay, and you have the two slopes like this. You know that the two lines are perpendicular to each other. And I put a number of homeworks on the line. Just make sure that you guys practice and have a chance to review or recall the properties of the line. Okay. And this is all for Appendix B. And one more time, let me double check on this before I move on. Yep, that's it. Now I'm going to move on to the very last appendix on our review on this video clip today. This Appendix B is about trigonometry. So I know that for you guys to take Calculus 1, you're going to get through trigonometry. But it turns out that there's too many formulas in trig, and you may not know them all, or maybe forget, and that's okay, that's normal. That's why we have review today. I'll give you step by step, okay? Review, make sure you guys get it. So, to measure an angle, first of all, circle, or any angle. To measure an angle, we use two types of measurement, radian or degree, okay? Radian degrees, like 180 degrees is equivalent to 1 pi. Okay. And of course, it's what? 360 degrees means that the entire circle is going to be 2 pi. 90 degrees going to be pi over 2. 60 degrees going to be pi over 3. 45 degrees is pi over 4. 30 degrees is pi over 6. 30 degrees is pi over 6. So forth and so on. You can either use degree or radian, but I'm glad that most of the time we mathematicians prefer to use radian because it's easier to work with. Okay. And then we have some basic trig function. You guys can start from a unit circle or the right triangle. This is a B here, C here. Okay. So Pythagorean theorem say what? A squared plus B squared equal to C squared, right? And we have technically only 3 trig functions, but we make it 6, so let's call it 6. Start with sine. Let's call this angle right here theta. Okay? So sine of theta. Sine is opposite over hypotenuse. So B over C. Cosine of theta. Cosine is adjacent over hypotenuse. It's going to be A over C. And then tangent of theta is going to be opposite over adjacent. It's going to be B over A. And I claim that that's good enough for you guys to do all the math. But we're going to do more out of it. After having sine theta, now let me go back with that. You got tangent, something called cotangent of theta. Cotangent is the reciprocal of tangent, which is going to be B over A. And for cosine right here, we have something called secant theta, reciprocal of cosine. So let me write down. Cotangent is 1 over tangent, which is B over A. Secant of theta is 1 over cosine theta, which is C over A. And we have something called cosecant theta, which is 1 over sine theta, which is C over B. Okay, now you got all the 6 trig functions. Now here comes some basic trig identity. Okay, we're going to start with the Pythagorean theorem. Okay, a squared plus b squared equal to c squared. This is the same thing as sine squared theta plus cosine squared theta is equal to 1. See why? Sine squared is b squared over c squared. Cosine squared is a squared over c squared, which is a squared plus b squared over c squared. And a squared plus b squared is equal to c squared. So c squared over c squared equal to 1. Okay? That's the Pythagorean theorem. Okay? And we have some modification of this Pythagorean theorem. If you divide both sides by, say, sine square, divide both sides by sine square, you got what? Sine square divided by sine square is 1. Cosine square divided by sine square is cosine divided by sine. Oh, I forgot to mention that. Tangent right here is, tangent theta is sine theta over cosine theta. So cotangent theta is reciprocal to cosine theta over sine theta. Okay? So cosine square plus sine square is cotangent square. Theta equal to 1 over sine square. And you know that 1 over sine square is cosecant square theta. Similarly, if I divide both sides by cosine square, so sine square divided by cosine square, you got tangent square theta plus cosine square divided by cosine square is 1, so tangent square plus 1 is equal to 1 over cosine square, and 1 over cosine square is secant square. Okay, and again, I'm going kind of fast because I believe this is a very basic one on trigonometry. You can always encourage to open your trig book or just Google it online, okay, to look over those material before we start our calculus 1. Okay. And let me just put out more formulas that I believe is going to be useful for our calculus 1. Even is honest. Sine theta will be equal to negative angle. So sine of negative theta will be equal to negative sine of theta. Cosine of negative theta is equal to cosine of theta. And to explain this, let me talk about the unit circle. Say this is a circle, origin right here, 1 right here, okay, 1. Okay, you have an angle theta. This is angle theta, okay? And this is the point on the unit circle. You project it down to the x-axis, it's going to give you cosine value. This is cosine theta. You project it down to the y-axis, you have sine theta. Okay? Now this is the angle theta. If you move downward this way, you have the angle negative theta. Okay? So, see, cosine of negative theta going to be equal to cosine of theta, because those 2 points, when you project to the x-axis, you have the same thing. Whereas you project this point to the y-axis, this is going to be opposite of that sine theta, so this is going to be negative sine theta. I'm sorry, negative sine of negative theta. Okay, so the opposite, negative sine of theta. That will work. Okay, so this is opposite angle. And I'll tell you what, the function sine is actually the arc function. Arc function. Arc function. Because if you change the input to the opposite sign, you have the opposite sign for the output. For cosine function, you call the even function, because you change the sign of the input, you get the same output. Graphically, graph of sine function will be symmetrical. Arc function in general, make it that way, will be symmetrical about the origin. And the even function will be symmetrical about the y-axis. This is even function. Okay. Now let me just provide some more trig identity that I believe is going to be very useful. for your calculus 1. Sum of angles formula. Sine of A plus B gonna be sine A cosine B plus sine B cosine A. Okay? Whenever you're going to calculate sine of sum of two angles, you can break it out. Sine of the first angle, cosine of the second angle, plus sine of the second angle times cosine of the first angle. How about sine of A minus B? It's going to be sine A cosine B minus sine B cosine A. So what am I doing? Just change the sign, minus to minus. Okay? But it's going to be a little bit different when you deal with cosine. Cosine of A plus B equal to sine A sine B minus cosine A cosine B. Oh, I wrote it backward. I'm sorry, guys. I wrote it backward. Cosine first. Cosine A cosine B minus sine A sine B. Let me double check and see which way is right. Let me see. Oh yeah, I got it right. And then cosine of A minus B is gonna be cosine A cosine B plus sine A sine B. Those are the trig identities that I claim you guys are gonna see very often in calculus, especially in Calc 2. When you have to deal with integrals, trig integrals. Okay? You're going to see a lot in Calc 1 as well. More. Oh, sine, cosine, how about tangent? Tangent of A plus B is going to be tangent of A plus tangent of B over, it's going to be a fraction, okay? Tangent of A, 1 minus tangent of A. 1 minus tangent of A times tangent of B. And for the subtraction, tangent of A minus B will be equal to, you change the sign of both numerator and denominator. Tangent of A minus tangent of B over 1 plus tangent of A times tangent of B. Okay? Those are sum of two angles formula. Now, what if A and B is the same number? In other words, you want to calculate sine of 2A. Think of it as sine of A plus A. It's going to be 2 times sine A cosine A. Because what? A and B is the same, so sine A cosine A, sine A cosine A, so 2 times. What if you have cosine of, I say cosine, right? Cosine of 2A. Cosine of 2A is going to be what? Cosine square of A minus sine square of A. And if you apply the Pythagorean theorem for sine and cosine, it's also equal to 2 cosine square of A minus 1. It's also equal to 1 minus 2 sine square of A. Okay? We have 3 ways to deal with cosine of double angle. Alright? And from this one right here, you can even modify. You have what? Cosine square of A. Want to bring down the angles. Cosine square of A is going to be 1 plus cosine of 2A. Cosine of 2A, right? Over 2, or sine square of A is equal to 1 minus cosine of 2A over 2. I got it from here. This is cosine of 2A, right? Cosine of 2A, right? So what? Sine square, what? 1 minus cosine of 2A divided by 2. Cosine square is cosine of 2A plus 1. 1 plus cosine of 2A over 2. Just play around with the formula. And I claim those are the very useful formulas. Everything that I wrote up in here, you guys are going to see it's very often in calculus, especially Calc 1 and Calc 2. Okay? Okay, a couple more, then we're done for flip the last couple of formulas, I claim that you see sometime in count 1, but you guys definitely going to see a lot in count 2 when you deal with trig identity. So we have this. Now we have from product the trig of 2 angles. Now what? Product of 2 trig function. Sine A cosine B equal to 1/2 of, I think it's cosine. Let me double check. Make sure. Yeah, 1/2 of, oh yeah, sine of A plus B plus sine of A minus B. Okay, that's 1/2. Usually I bring a 2 in here. 2 times of sine A cosine B equal to say A plus B sine of A minus B. The book write this way. We do the same. To make it easier, let me just do it one way then. I can get rid of that parenthesis. I'll write a 2 right here. 2 times of sine A cosine B equal to sine A plus B plus sine of A minus B. And I'll tell you how I look at it. I'll just say, well, sine plus sine equals 2 sine cosine. Sine plus sine, okay? And the other one, we have, how about sine plus sine? How about 2 times sine A sine B? Sine A plus sine B is cosine. Okay? So cosine. Cosine of A plus B plus cosine of A minus B. Right? Co. This is how I used to say co plus co is equal to 2 sine. Right? And it's short. Then the last one is gonna be what sine cosine. You can change the order. Cosine sine is gonna be the same. Sine sine. So the last one is gonna be cosine A, cosine B. Of course, instead of dividing both sides by 2, write a 2 the other side. Put a 2 here. Okay. Now it's gonna be changed. It's gonna be opposite. So instead of cosine plus cosine, it's gonna be cosine minus cosine. And we only have to change. Also have to change the angle. A minus B in here, and then A plus B in there. All right. And as you see, honestly, I do not remember all of those formulas at once. But when I write down, it's going to come back, and the easiest way, in my opinion, to get all the formulas is to practice. Okay, you do some exercises, and if you don't remember, it's okay. Just derive it by yourself, or just look up on the back of our book. So the purpose of this appendix is to provide you some formulas, and later on, you'll be convinced that those formulas will be very useful when you learn Calculus 1, because many problems need those formulas to solve the problem. Okay? And let me stop this video clip right here. Thank you for watching, everyone. Hopefully, those formulas that I provide are going to be helpful for your learning later on. And of course, if you have any question, please ask. Email will be the best way, or we can set up the time to be online together, and we can chat and take care of the problem. Whatever question you have. Right. Have a good day. Bye-bye.